Hello, welcome back. We're going to do another binary search problem today. Today's problem is 1482, minimum number of days to make m bouquets. We have a garden consists of n flowers, and our job is to make m bouquets. We're given an integer array bloom day. This tells us which day the flowers will bloom in the garden. We are also told that in order to make one bouquet, we need to use k adjacent flowers from the garden. Our task is to figure out the minimum number of days we would need to wait to make m bouquets from this garden. Now let's do an example together. In this example, we need to make 2 bouquets. In order to make one bouquet, we need 3 adjacent flowers in the garden. The bloom day array is this. The first element is 7, the second element is 7, and so forth. The value 7 means that we have to wait 7 days for the flowers to bloom. In this example, the first 4 flowers, it would take 7 days for it to bloom. And in this value here, we have to wait 12 days for that flowers to bloom. And then 5 days for this one, and 6 days for this one. For this garden, on day 1, no flowers will bloom. And on day 5, only this flower will bloom. By day 7, we have these flowers that are bloom. In this example, we need 3 adjacent flowers in order to make one bouquet. So day 5, we are not able to make any bouquet because we only have the 1 flower here. On day 7, we have quite a number of flowers, so we can make a bouquet. So we can make a bouquet from these 3 flowers here, and that's it. So on day 7, we can make one bouquet. On day 12, we have these flowers that bloom. We cross out the flowers that we have already picked to make the bouquet on day 7. And we still have plenty of flowers left to make another bouquet. We can pick these 3 or these 3. It doesn't really matter. By day 12, we are able to make 2 bouquets. One on day 7 and one on day 12. And we are done because 2 bouquets is what we need. The solution to this example is that we have to wait 12 days to make 2 bouquets. Basically, this problem is just that we will try day 1, day 2, day 3, and so on. And we can figure out how many bouquets we can make from each day, and we are done. This question is actually very simple. What is the minimum number of days we have to wait before we can consider whether we can make a bouquet or not? Well, the minimum number of days we have to wait is the minimum value of the bloom days array. For example, in this case, the number of days we have to wait is at the minimum number 5 because nothing will happen on days that are less than 5. What is the maximum days we have to wait in order to consider whether we can make a bouquet? Well, the maximum days we have to wait is the maximum value of the bloom days array. For example, in here, we wait at maximum 12 days because by that time, every flower has already bloomed, so there's no point waiting longer than 12 days. If you have been following this series, you will realize that, again, we have a search problem. The search space is to try every day from the value of minimum of the bloom days array to the maximum of the bloom days array. This strategy is a linear search within this range, and we can always upgrade that to a binary search within the same range. Let's start pseudocoding the solution. Again, we will start with the template for binary search. The low value is the min of bloom day. The high value is the maximum of bloom day. Again, we will have a response parameter in which we're going to set to -1. This is the parameters we'll return at the end of the function. So while low less than or equals to high, we're going to establish the mid value. And then we're going to pass this mid value, which is the number of days we have to wait in order to get all the bouquets. We're going to pass this value to this getBouquets function. And we're going to also pass in bloom days array, number of bouquets that we have to make, and the stipulation of how many adjacent flowers is needed in order to make one bouquet. Now, if this function returns true, then we have found a day where we can make all the bouquets, in which we're going to set the response parameter to the mid value. And then we're going to set the high value to mid -1. We want to see if we can find a lower number of days that we have to wait. If this getBouquet function returns false, so we know that's not going to work, then we're going to search the upper half of the range by setting low equals to mid +1. And at the end, we're going to return the response parameter. Let's talk about this can getBouquets function. we're going to have flowers picked so far, and we're going to iterate the array of flowers. If the flower sub I is less than the day, that means the flower has bloom. So we're going to stop picking. If not, then we're going to set this flowers picked to equal to 0. Now, if we continue to pick and that number, the flowers picked, is equivalent to adjacent flowers, so we have X number of flowers in a row, then we reset the flowers picked to 0, and then we subtract the number of bouquets by 1. If the number of bouquets is 0, that means we have finished picking all the bouquets, then we will return true. Otherwise, this will return false. Let's go through the example on the right. So on day 5, we will start picking from this flower, and we'll pick 2 flowers, but we need 3 flowers in a row to make a bouquet. So by the time the iteration reaches this point, the flowers picked will be equals to 0. And then we will go through the next flower, and we only have the 1. So this iteration will finish. Now on day 7, we will start again picking from the left to right. By the time we reach this position, we have found that the number of flowers in a row is same as the number of flowers that we have picked. Then we can make a bouquet. Then we can proceed to make a decrement of the number of bouquets needed. And then we will start picking again at this position. Again, we only have the 1 flower, so we are done. By day 7, we're able to make 1 bouquet. Okay, now that we talk about the pseudocode, I just convert the pseudocode to C# code. This is provided in the GitHub links below. In addition, from the .github link, you can also find the Python version of the same code. In the top portion, we just have the binary search template, and here we have the canGetBouquet function. Everything is the same as in the pseudocode. All we have to do now is test whether it works. And it looks good. In this series, we have done 5 questions with binary search. They all follow a similar pattern. Hopefully these examples are helpful to you. Let me know what you think about this series. Good luck on your interviews, and hope to see you next time.